All right, so we're in section 3, add and subtract square roots. Now, the hardest part about this is just simplifying the square root. So let me write that down real quick. So the hardest part is going to be simplifying our radicals. Okay? The easy part is you already have a really good understanding on how to do this, which is combining like, and before you say terms, because I know that's what you want to say, we're going to be combining like radicals. So basically, it's a two-step process. Step 1, simplify your radicals. Step 2, combine all the like radicals. And that's it. So let's just start off with a couple examples, very easy ones. 2 times the square root of 2 minus 7 times the square root of 2. Now, notice that the radicals are the same. Square root of 2, square root of 2. So really what I'm really asking here is, what is 2 minus 7? And 2 minus 7 is negative 5. And then you tack on the square root of 2 right behind it. So if you think about it, if I asked you the question, what's 2x minus 7x, you would approach it the same exact way. You would say, well, the x's are the same, so 2 minus 7 is going to be negative 5x. So between these two examples, there's nothing different. The only difference is, instead of using a variable, I'm using a radical symbol now. Let's go ahead, let's do another easy one like this, and then we'll get into the more difficult ones. How about 3 square root of y plus 4 square root of y? Notice that the square root of y's are the same, so 3 plus 4 is 7 square root of y. All right? It doesn't matter if you have 2 or 10. I don't care. The process is still the same. Notice in this example, we have 4 square root of 11 plus 2 square root of 11 minus 9 square root of 11. Well, they all have a square root of 11, so what I'm really concerned with is 4 plus 2 is 6, and 6 minus 9 is negative 3 square root of 11. Okay? So now the question becomes, all right, well, what if you got variables? Well, it really doesn't change anything. Let's say we have 5, or the square root of 5xy, plus 4 square root of 5xy, minus 2 square root of 5y. Okay? That looks like a G. Let's make it a y. Now, no, I didn't make a typo here. I did this deliberately. Notice the first two terms both have the square root of 5xy. So it's just 1 plus 4, which is going to be 5 square root of 5xy. And that minus 2 times the square root of 5y, there's nothing I can group that with. So you just write it. There's nothing you can do about it. Remember, you're combining like radicals. Okay? And then naturally, the next question would be, well, what if we don't have like radicals? Do we just move on, or do we try to simplify? And it goes all the way back to the beginning of this lecture, which is step 1, you simplify. Step 2, you combine your like radicals. So let's look at this let's look at this problem. We got the square root of 20 plus 3 times the square root of 5. Now clearly these two radicals are different. However, maybe I can simplify one of them. So I'm going to look at the square root of 20 first. Square root of 20, we know, is the square root of 4 times 5, which is going to be 2 square roots of 5, and we simplify. So from here, I'm just going to rewrite this as 2 square root of 5 plus 3 square root of 5. And now look, the radicals are the same. They're both square root of 5. So 2 plus 3 is 5 square root of 5. And I mean, that is as hard as it gets, to be honest. I'm not joking. It's just simplifying. You got to be able to simplify your radicals. So I'm going to do a couple more of these examples here. So how about 4 times the square root of 27 minus 3 times the square root of 12? Well, off to the right-hand side, let's break down these square roots. So this is going to be 9 times 3, which is 3 square root of 3. Minus, now, this second one, we got to be careful. You'll see why in a second. Square root of 12 is really 4 times 3, which is going to be 2 square roots of 3. Now, the second one, like I said, you got to be careful because if you notice, you already have, it's 3 times the square root of 12. So this is going to be 3 times 2 times the square root of 3. And 3 times 2 is going to be 6. So this turns out to be 3 square root of 3 minus 6 square root of 3. Notice the radicals are the same. 3 minus 6 is negative 3. Square root of 3. Okay, let's do a couple more here. All right, I know you just love these ones, so we might as well do them. 2/3 times the square root of 48 minus 3/4 times the square root of 12. Now, got to be honest with you, this isn't as bad as what people think. Let's break down these radical signs first. 48, we looked at that one earlier. That was 16 times 3. So that's going to be 4 times the square root of 3. 12, we just did that one. That's going to be 4 times 3. So that's going to be 2 square root of 3. So what I'm going to do is I'm going to write 2/3 times 4 square root of 3 minus 3/4 times 2 square roots of 3. And then from here, we just got it. We got to simplify. We got to be careful. Now, 2/3 times 4, nothing reduces. So you just got to multiply. So it's going to be 8/3 square root of 3 minus. Now, the 3/4 times 2, if I come over to the right-hand side, we know 4 can be rewritten as 2 times 2. So I can reduce one of the 2's. So this is going to be 3/2 square root of 3. Now, if you notice, the radicals are the same. So I know I'm going to have a square root of 3 for an answer. The question becomes, what's the number out front? Unfortunately, you're going to have to go ahead and subtract 8/3 minus 3/2. So I'll leave you to do that. I'll just tell you that the final result is 7/6. So this turns out to be 7/6 square root of 3. Okay? I could try to make these a little bit more difficult just by giving you harder problems to simplify. For example, nine times the square root of 50m squared minus 6 times the square root of 48m squared. Well, nothing changes. We need to simplify. We need to simplify the radicals. So we'll do it one at a time. Square root of 50m squared. We know square root of 50 is 25 times 2, m to the second. Square root of 25 is 5. Square root of m squared is m. And you got the square root of 2 left over on the inside. So this is going to be 9 times 5m square root of 2 minus square root of 48 m squared. Well, we know, let me think about this here. We did this one earlier, so it's going to be 16 times 3 m to the second, which this is going to reduce down into 4 m times the square root of 3. So we have 6 times 4m square root of 3. Now, 9 times 5 is 45. M square root of 2 minus 6 times 4 is 24. M to the square root of 3. And notice that the radicals are not the same. Therefore, we cannot combine these. So that's as far as we can go. You will run into that situation. Not a lot, but I will definitely put something like that on a test just to make sure you know what you're doing. Okay? Let's try one more here. So how about 7 square root of 48y squared minus 4 times the square root of 72y squared. All right. Process is still the same. We need to reduce these square roots. Square root of 48y squared, 16 times 3y squared, which we know breaks down into 4y square root of 3. Now the 72. Let's break that down. 72 is going to be 9 times 8 y squared, which is the square root of 9 times, watch this now, 9 times 4 times 2 y squared. And if I drop this straight down, square root of 9 is 3, square root of 4 is 2, with a y and a square root of 2 left over on the inside. So if I take all this stuff over here, oh, let me simplify this down a little bit more. So if I take my 4y to 4y square root of 3, 6y square root of 2, and just move it over here, 7, 4y square root of 3 minus 4 times 6y square root of 2. I run into the situation just like previously where I can't combine them, but I can go ahead and simplify this down a little bit. 28 y square root of 3 minus 24 y square root of 2. Okay? Now for the final problem here, we'll look at one where we can actually do a lot. So we have 2 times the square root of 8x squared minus 5x times the square root of 32 plus 5 square root of 18x squared. All right. So here it's just going to be a lot of simplifying. Square root of 8x squared is going to be 4 times 2x squared. Square root of 4 is 2. We know we can pull out 1x. And we have a square root of 2 left over on the inside. So what I'm going to do is I'm going to say 2 times 2x square root of 2 minus. Now we're going to do the square root of 32. Well, 32 is 16 times 2. So that's going to be 4 square roots of 2. So this is going to be 5x times 4 square root of 2. And finally, the 18x squared. Well, 18x squared is really 9 times 2x squared, which we know that's going to be 3x square root of 2. So this would be plus 5 times 3x square root of 2. Now, let's clean it up. 2 times 2 is 4x square root of 2 minus 5 times x times 4 is going to be 20x square root of 2 plus 5 times 3 is 15 x square root of 2. Now, I got to pull my highlighter out here because I need you to see this. Notice each one of these terms, and you got to be careful because now not only do they have variables that have to match, but they also have radicals that have to match as well. So we have x square root of 2 for each of them. So I know my answer is going to be x square root of 2. The question becomes, what's the number? Well, 4 minus 20 is negative 16. And negative 16 plus 15 is negative 1. So this is going to be negative x square root of 2. And that's basically it for this section. It's all about, and I'm going to scroll all the way back up. It's all about simplifying the radicals and then combining like radicals. That's it. Okay? So I will see you in the next video where we talk about multiplying square roots, and then we'll divide square roots as well. See ya.